So the next speaker will be Erez Korn from AT&T. Hi, Erez.
Well, more people than I hoped for. Yeah. So, I'm Erez Korn. I've been with AT&T for about 15 years now. I was a lead architect, a development manager, and my current role is product tech innovation lead, which means I have the luxury of dipping into new domains and trying to incubate significant activities around them. I love technology. I love science fiction and fantasy books and movies. And as for hobbies, with 6 kids at home, my wife and I always have something interesting to do. So some of you have seen Rinat Zilberstein yesterday. She manages AT&T Israel, and she was talking about a system that we created that democratizes flow optimizations across the entire product development lifecycle. At its core, that system is powered by the code understanding use case for retrieval augmented generation, or RAG. Now, probably all of you know RAG, but let's level set just in case. So RAG integrates retrieved documents into the input of a large language model in order to create more informed and accurate responses. The retriever fetches relevant documents or passages from a large corpus based on the input query, and the generator uses these documents as context to generate a coherent and relevant response. For example, consider the query, how do I fill an expense report? A traditional LLM would provide a generic response that wouldn't really help me as an employee. However, with RAG, with its store of local knowledge, with it, the answer may look something like, at Acme Inc. to fill an expense report, go to the employee portal, head over to the finance section, and click expense report, etc., etc. Now, incorporating the retrieved documents into the context also helps ground the responses in factual information, reducing the chances of hallucinations. But RAG isn't without its challenges. I'll go over only a couple of them for the sake of time, a couple that are more relevant to our use case. So first of all, in large data sets, RAG systems can struggle to distinguish between closely related topics. The issue is even stronger in specialized domains where nuances are really important. For example, let's say someone tries to ask about quantum entanglement in superconductors, which is complete Greek to me. The model in a large data set may instead bring documents about general quantum mechanics or general superconductors, missing the specific intersection between the two topics. Words with multiple meanings can lead to confusion in RAG systems as well. This confusion can result in the retrieval of irrelevant or incorrect information. For instance, for the question, what are the benefits of the new large screen Mac, I can get an answer such as, it goes well with Coke and fries, and there's even a larger version, the double Big Mac. There are more challenges, but I'd like to move on to look at a few advanced RAG techniques that may produce better results depending on your specific knowledge domain. So let's start with RAG fusion, where you basically multiply the retrieval process. It involves a multi-step process to enhance the accuracy and relevance of responses by creating multiple queries from the original query. Let me give you an example. So let's say the original query is about benefits of electric cars. The model can generate the following sub-queries. What are the environmental benefits of electric cars? Provide a comparison to gasoline cars. What governmental incentives can I get when I want to purchase an electric car, and what are the cost savings I can expect from electric cars. Now, each subquery retrieves a set of documents that are then re-ranked together based on a combined score, ensuring that the most relevant documents are prioritized. Finally, the re-ranked documents and all of the original subqueries will be sent to the model to generate a response that will address all of the aspects of the original query. So RAG Fusion offers several significant advantages. In what is essentially a side effect, it corrects the grammar and spelling errors of the original query, and it ensures that the user's intent is accurately captured. The process results in responses that are more relevant and comprehensive. By drawing information from diverse documents, it provides holistic and well-organized answers that aligns with, as I said earlier, with multiple aspects of the original query. And it's, for some reason, also seems to reduce the frequency of I don't know responses that everyone that dealt with RAG experiences. Finally, there's also an easy way to implement RAG Fusion with LangChain, but that's beyond our scope today, and probably you'll tell me to hurry up if I try. Even though it has benefits, there are also several drawbacks to RAG Fusion. So it can result in longer response times because I generate multiple queries using the model, and then I retrieve multiple documents. And the subqueries themselves sometimes may be irrelevant, which will cause irrelevant information to be pulled into the context as well. Moreover, RAG demands significant computational resources and can be challenging to maintain. The integration of diverse sources may also result in inconsistencies or even conflicting information within the context that will carry on to the response itself. The next technique involves AI agents. So AI agents are software programs that are designed to perform tasks autonomously by interacting with their environment, with other agents, and with humans. They can utilize large language models, human inputs, and various tools to achieve their goals. So here's an example of me asking an agent to create the complete snake game. As you will be able to see, it will even install missing libraries for me, create the game, and then launch it. And well, it may be a bit embarrassing, but it takes less time for the agent to create that game than, as you can see, for me to be able to catch the first piece of food. So we're using AI agents when we want to use reasoning to determine which actions to take and in which order to take them. So how can they improve RAG? Well, we can integrate agents into RAG at various points. The agent is able to analyze the incoming query to understand its intent, complexity, and specific requirements. Based on the analysis, the agent considers the agent selects the most appropriate RAG pipeline. And if that pipeline is, for example, RAG Fusion, the agent can also create the subqueries themselves. The agent considers the context in which the query is made. Let's say there's a customer support scenario. The agent can then pull all of the ticket history of the specific user and then insert that information into the response to create a more relevant response. The next technique is one that we're currently experimenting with. It's called reverse RAG. That's the last one I'm going to discuss today. And it's called reverse RAG because the generative process precedes the retrieval mechanism. And then the initial generation provides a context that guides the retrieval process. For instance, if the initial query is about cloud computing, the initial generation, the initial text will include points about cost savings and scalability. This will guide the retrieval of specific documents that expand on these points. And in turn, the retrieved documents will also provide a validation mechanism for the initial generation. Reverse RAG initial generation initial text generation can also help to pull multimodal information for our use case. That means, so it can be pictures and image and videos, of course, but in our use case, that usually means diagrams that describe the code. I'm not talking about diagrams that are generated by the system, but rather diagrams that are already there. Maybe the architects created them, and the initial generation here will help describe what we want to pull. And another thing for the code understanding use case, enriching the initial prompt with fixed knowledge about how the system is built can also significantly improve the performance and accuracy of reverse RAG. So a question like, how is login handled in our application can be enriched with a system prompt or an initial prompt that describes that the application uses Python logging, that it uses custom log handlers for log storage in a central place, and that it has 3 log severity levels. That enriched prompt and initial generation will guide the retrieval process to fetch documents and code snippets and diagrams that are related to the question. Am I on time? So, we've covered only 3 RAG techniques today, and there are many more, and more are created regularly. And you will want to experiment with them, and when you're sure about them, you'll want to integrate them into your own system. And in my view, it's all about creating a safe place for experimentation. One strategy for that is to establish an always running leaderboard. You can create a sandbox where different RAG models can be tested against a set of benchmark queries and a truth set. Only switch into a specific model or a specific pipeline when it reaches one of the top places in the leaderboard. It's important to remember that this is a journey because new techniques are being created daily. You'll need to always be prepared to try new ones. And the good thing is that there's a very active community that will be happy to support you. In our case, for code understanding, we found that the mix of the techniques that I described today work best. But that's actually only what our leaderboard is telling me today, and that can change tomorrow when I try a new one. So we are continually exploring new techniques, and I'm excited to see what innovations will come, maybe even from this community. I want to thank you, and if you have any questions, I'll be happy to answer.